Right guys, welcome back to a brand new video. I'm very excited for this one, and I know I always say that, but today I really am. We're going to be playing a game, more specifically the Turing Complete game, and we'll get onto that very, very shortly. Just to give a bit of context as to how I found this game and why I'm playing this game. The last video that I made, I created a simple Hello World program in assembly for ARM64 on my MacBook, and it went pretty well. I got the Hello World working, but I did mess up and have an error at the end, but nonetheless we got it working. That's all I wanted to do in that short video, and just to explain to people who are absolute beginners what assembly language is effectively. But people in the comments were, along with flexing on me, were talking about this Turing Complete game. And when I say flexing, I mean that people were saying that they had handwritten machine code. Some people were saying they had written assembly language professionally for a few years in industry, which is phenomenal, by the way, and I'm very envious of you, of those of you who can do that, or have done that in a past life, okay? So, you know, it's incredible. And people were in the comments then were talking about that Turing Complete game, so I had to give it a quick look, and I found out effectively that it wasn't what I pictured it would be, which is a shoddy done game on the browser somewhere. In fact, it's actually a game you can get on Steam. So I downloaded it, I looked at the game design, it's fantastic. So in this video, we're going to play around with that. And for those of you who don't know what the Turing Complete game is, because I didn't at first, I thought they were on about the Turing Complete concept with languages and so on. But it's effectively a puzzle-solving game where you build a computer from the ground up from a NAND circuit, which is a not AND circuit, a not AND gate, sorry. And then you can build your own processor, you can go ahead and build your own assembly language. I've seen people create the Intel, or seen somebody create the Intel 8008 processor, which is mind-blowing. So people were getting it to play games like Snake and so on. Absolutely fantastic. So it goes to show how powerful this game is, because it's teaching you literally all of that from the ground up, if you take it seriously, and if you just don't kind of breeze through it with the hints and the cheats and all that, okay? So I hope you enjoy this video, and I look forward to seeing you in the next one. Please enjoy, and leave comments and like and subscribe and all that fun stuff. Bye. Or if you think about buying the game, maybe this is a good place to start, okay? So let's get to it then, okay? So congratulations, you have been abducted. We are testing you on our spaceship. Build a fundamental computer and your species may join the Galactic Federation, okay? This first test checks your understanding of circuits. Here you have an input and an output, with a wire in between. Okay, so turn on the input in the left-hand menu to complete it. Okay, right. So I'm assuming we just click this and that does it. Okay, fantastic. So effectively we press on or off, and based on whether it's on or off, that's represented effectively as 0 and 1 on a computer, okay? All of the animal species on Earth are going through the same test to see if you have the same the intelligence to learn to build a computer. Okay, this is just going to be insulting now, isn't it? There's going to be some digs in there along the way, I'm sure. But the first section then is about Boolean logic. So Boolean logic describes the simplest form of calculation computers can do, sorry. In fact, these calculations are what every other calculation in the computer is made out of. Okay, right. So the circuit contains a NAND gate. So a NAND gate means effectively not AND. Okay, so AND means if you get two inputs that are 1, you get a 1 as an output. Okay, so anything, it has to be 1 and 1 to get the true value. Okay, I haven't done truth tables since I was in university as a student myself, and I haven't taught truth tables, so this will be all. This will be a very good refresher for me, and it probably more complex as well in some sense. I want you to document its behavior by filling in the truth table in the panel you see below. Only the 2 input rows of the truth table are filled out. Your task is to experiment with the inputs to the circuit, observe what the NAND gate does, and fill the last row of the truth table. Right, okay, so I'm going to go with my assumption here, which is that this should be green, this should be green, this should be green, and this should be red. But let's try that first. So we have 2 greens, which give us a red. So that's a 0, okay, so we get a 0 as the output, which is what again, we get a 1 there, so I imagine that'll be the same if we have another 1, which is the case, and if we have none, we'll also have a 1. Fantastic, so that should be correct, and it is. So correct, you have unlocked the NAND gate, okay. By the way, we won't get too far in this video, I'm sure, but follow along if you've got the game, or if you're just watching this to see if it's worth buying, then by all means. Okay, so correct, so you have unlocked the NAND gate. pardon me, out of this fundamental building block, you will construct everything else in your computer, which is quite incredible when you think about how far we've come. And it's always mind-blowing to just think that everything in your computer that's happening right now comes down to zeros and ones that are being executed at a lightning fast speed. It's incredible. So, right, we're on to the next one now. Now that you have unlocked the NAND gate, it's time for you to build a circuit yourself. Okay, so in the last level, you made the truth table that described the circuit. In this level, you build the circuit that matches the truth table. Okay, so effectively, we use the NAND gate, which is over here in the right-hand panel. So we have to build, so using the NAND gate, we have to build NOT. Okay, so we have to effectively say, if it's a 1, we get a 0. If it's a 0, we'll get a 1. So it's effectively saying it's the opposite of whatever it is we're expecting. So if we do this, then we have to effectively create a NAND gate, which is interesting because I'm not sure how we do this, first and foremost. So, right, okay, click anywhere on the board. So can we just have effectively 2 wires come out like this, wire come out like that, click play, and that is complete. Okay, but let's have a little look at that first then. Okay, so quite literally, if we have 2, we're not choosing, oh, well, I guess if we turn that off. Yeah, so using one NAND gate, we can create the NOT gate effectively then. Is that correct? So if I turn that off, we get green. If I turn it on, we get red. Okay, that's good. Yeah, so that makes sense. Right, okay, so what have we done so far? We've done the humble beginnings, NAND, and the NOT gate. So we use WASD to move up then, WASD, and you can see as you go up, it gets more and more complex. And the idea is then, like, you create your own multiplexer, which is quite cool. And we get into arithmetic, so the ALU. It's actually fantastic. Again, how all of this comes from zeros and ones. So let's do the next one then. Okay, I guess that's the AND gate. So right now, the elephant is dominating all. I knew there was going to be digs in there somewhere. There had to be. So just wonder where the monkeys are. So right now, the elephant is dominating all the other test subjects from Earth. Adjusted for brain size, you are also doing well. Okay, that's good to know. So create the circuit that matches the table. Most levels have a hint. So if we're stuck, we can click on the light bulb up top then, okay? Right, so we have to, using the NOT and the AND gate, we have to create a AND, which I assume would be very similar to the last one. We use a NAND, and I'm assuming, given the fact it's given us a NOT now, so I'm just kind of breaking this, we can use a NOT as well, because it's going to be the opposite of NAND. So is that correct? So if we have a 1, we have a 1, we have a 0, which is correct. So if we have a 1 and we have a 1 and a 0, we get a 0. If we have, let's change this to the other one as well. It should be the same. And that will be the case as well. So we'll get a 0. And if we do this, we get that. And if we do this, we should get a 0 as well. And that is the case. So, right, fantastic. So that's done then. I think we got that correct. Awesome. So we've now unlocked the AND gate. So now we have to do NO. Okay, so that's not O. This one's going to be a bit tricky because I don't know how we would do that. I assume that we just move the NOT to before. So it should look something like this, perhaps. Or maybe, let's try this first. So we'll do that. Okay, we can delete things as well, so let's do that right now. Right, so we have this. Go here, let's go here, oops. Let's go here, and let's try that. So what does that give us? I'm just playing around with things now. Again, it's good to experiment. I don't think anybody could get this right first time. So 2 zeros will give us a green, which that is the case for now. If we have 1, we'll get, okay, that's wrong because we're getting a green. So we know that's not the case. So this is wrong. So what I'm thinking is we get rid of that. We'll keep that there. We'll have a NOT still somewhere. Maybe we could have 2 knots. Maybe that's what we have to do. So would 2 knots give us no? Let's have a little look. Let's do that. Let's try that. Again, I'm guessing here, so this is going to be tricky. So again, that's not correct. So that immediately makes me think that somehow we're going to have a knot here. Okay, right. So what are we getting? So we have to effectively, we only get a desired output when we get two zeros. Right, so effectively, right, we get a 1 if we pass through two zeros. So what do we get when we just pass through the NAND? What do we get when we just pass through the NAND? So, right, we're getting a green, but there, yeah, okay, right. So what we need is possibly, okay, this is going to be a tricky one. This is going to be harder than I thought. I didn't think this was going to be a walk in the park, but it's definitely going to be something that requires you to think a little bit about these puzzles, okay? Right, let's have a little think then. So we're only limited to and not. So the question is, we know that a NAND will give us a positive for every, in fact, right, NAND is going to give us a positive for every thing that is not AND. So it's effectively, this is effectively, okay, so we have to, see, this is really tricky. I don't know how the hell I'm going to figure this one out. Right, okay, let's just play around with things. So if we had that in here a second, and we just add this here, let's add another knot in. I think we tried this actually. Maybe we need another knot here. Right, okay, that's wrong. That is wrong. Or do we even need the NAND? I'm thinking we need to use the NAND, but maybe we don't. Maybe we just need a knot. I don't think that's going to be the case. Okay, let's just clear that. Right, okay. Wow, why am I struggling on this one? Right, I'm going to take a hint because I feel like I need it. Right, the truth table tells us that the NOR gate is on if and only if both the input 0 and 1 are off. Right, okay, so it's saying that we need to use two knots. So that is something that I did try to do in the first place. But let's try it again. So if we use not and not, we do something like this, like this. The thing is, we have to have the NAND in there somewhere though, don't we? So would it be like that? I'm sure I tried that earlier though. So if we have two zeros, right, this is where we got the issue. See, that's where I'm struggling because this is the desired output for 1 is not that, so it's not the case. So maybe we need another NAND gate. Let's get rid of that. Could we do something like that? That looks quite complex, but it seems to be working. If I have both on, sorry, I should get a 0. That's the case. And if I have both off, okay, that should do. I think that's it. Wow, okay, that was harder than I thought, but we got it done in the end. So let's try and get our heads wrapped around that really quickly. So effectively, we have both outputs which are becoming a NOT, and then we have them going through a NAND, which is, of course, again, it's not 2, 1, so it's going to give us a positive out of that. We have these going through a NAND, and again, NAND only returns a 0 if it's not AND, which is going to be 1 and 1, so that makes sense now. Again, in retrospect, it's always easier, but when you're working through it, it's actually quite difficult. I don't know, I'm curious how far you've gotten. If you're watching this, let me know in the comments how far you've gotten creating these. Hopefully I'll have less issues with the OR one. I didn't even read that then. Let me go back. Oops. Right, how do I go back to the menu? Level map. Okay, let's have a look. Right, create the circuit that matches the table. Okay. All right, okay, again, so we're limited to NAND and NOT. So let's have a little look at this one then. I think maybe this is going to be actually what I tried to do before, where we have a NAND and effectively, because that's the issue that I had before, wasn't it? That it's either we have to use 2 NOTs. Yeah, so I think we're going to have to use 2 NOTs. Oh, okay. Actually, no. Right. So if we have this, let's just see what happens. If we have 1 and a 0, we get a 0. If we have 0 and a 0, we get a 1, which shouldn't be the case. So effectively, whenever we have 1 as a tick, it should... Okay, it's not that. Right, we're going to need the NAND again. I know we need the NAND. It's more so psychologically. I'm thinking, right, we need the NAND, we need the NOT. But I'm trying to think. So couldn't we just do something like maybe perhaps this? So I feel like it's going to be similar to the last one, but it just misses out the step. Again, I'm not thinking about this logically, perhaps. But, right, that's correct, that's correct, that's correct, and that's correct. Fantastic. That should be it. Awesome. See, I knew it was going to be similar to the last one. I should have probably started with that one because that would have made more sense. Right, okay, we're on to always on now. So I'm curious about what this one's going to be. So create a circuit that is always green. So that's going to be an interesting one. Right, so let's have a wire going out here then. Now, I imagine it's going to have to split off somewhere. And we're going to have something here. So maybe we can have a knot here. And then join this up, is it? Would that be? No, we can't join. Okay. Right, how do I delete? Can I delete quickly? No, I can't. I have to use this. Right, great. Fantastic. I still feel like it's going to be something like this. So maybe we have an AND or NAND. Let's try dragging a NAND there somewhere. Let's clear that out. Let's get rid of that. Have that there. Let's have that connected up. So let's have... So if it's off, do we still get a green? We do. And if it's on, we still get a green. Fantastic. Okay, so that's it. So we have a NOT and we have a NAND, and that creates an always-on circuit. That seems pretty straightforward. I wondered as well, because this is something I haven't looked up, and it's something I might look up during this video, but are there a million and one ways to do this with the different components they're giving me? Because I imagine that would be the case. So we'll find out. Okay, De Morgan's law, right? Okay, this really is taking me back to my university days, which wasn't actually that awfully long ago, I suppose. But again, I know it's to do with truth tables, but other than that, it's a bit outside my comfort zone because I haven't done any discrete mathematics in a long time. Right, so the truth tables of the 4 fundamental gates are symmetrical, so you can convert between them by inverting the input. So vertical arrows or invert in the output. So inverting the input is the vertical arrows. Okay, so it inverts the input. Or invert in the output. Okay, right, so this inverts the input. And this inverts the output then, if we look at the horizontal arrows here. Yeah, this is the input, right, okay. Yeah, right, okay, that makes sense. Yeah, so this is inverting the output, so we have red, green, red, green. Oh no, clearly I'm getting confused somewhere. Oh no, sorry, right, the output. Yeah, sorry, I was reading the wrong one. Horizontal is output, right, okay, yeah, so here we have red, green, green, green. Here we have red, green, red, red, red. Right, okay, that makes sense. I'm not going to read this because I don't know if it'll come in handy later. If it does, I think we can open it up somewhere. So we're not going to worry and concern ourselves too much with that. Right then, let's have a little look at second tick. I think XOR is a good one to get up to for this video. I don't have any high hopes to get past that. But let me know if you guys are enjoying, because I could do more of this. This seems quite fun. This seems like something that would be good for a stream. And I know I've been talking about a stream for a while, but I'm happy to do that if people will be interested. It's such a cool layout as well. That's something I forgot to say earlier, by the way, is like I honestly intended this to be like a shoddy game in the browser, but it really isn't. It's fantastic. It's so well designed, and it's like this is a game that if I had kids, I would want them to play, because it is teaching them how computers work from ground up, which is something that we're so disconnected from, especially my generation. So I appreciate anything that can offer this in a friendly way. So regardless, that's what we're going to be doing. We're going to be playing this all day probably, and all night. Anyway, right, what are we doing here? So I did again, me being me. Let's go back to 11 map it. Right, okay. Output green on the second tick only. Okay, fantastic. Always on, always off. I have no clue what we're meant to be doing here. Right, so if we get a 0 and a 0, we get a 0. If we get an on and a 0, we get an on. If we get an off and a 0, we get an off. If we get... Okay, this is... okay, I thought this was going to be an easy one, but clearly not. Second tick only. Right, let's have a look at a hint. I'm going to need a hint on this one. So we need a NAND gate. So the truth table tells us that that the output is on. If, and okay, I think they give us more hints here as well. I don't want to view the solution, so I'm not going to do that, but it's just good to know they have that there. Right. The truth table tells us that the output is on if and only if the output 0 is on and the output 0 is off. Right. Okay, so if input 0 is on and input... okay, so we only get that if the 1 is on. Okay, right. Right, okay, so to get through to the next site then, if I exit hints a sec, so we need to pass through an AND by the sounds of it. That just seems to be a given. So if I have that there, and I pass these through an AND, that might need to change, but we'll deal with that as we come. So what we're saying here then is that if they're both on, okay, then that means that we would get a 1 only if we have... We get a 1 only if we have both 1s as inputs. Here, we're saying that input 0, we only get a green if input 0 is... Okay, so I feel like we've got to split things up, actually. I feel like we've got to split things up. So maybe this AND needs to come a little bit later. This is going to be tough. It's going to be really, really tough. See, this is why I need to live stream this, because I can ask for hints off you guys without actually looking at the hints of the solution. So we quite literally need input 1 will end up giving us... Right, I need to look at this again. So the truth table tells us that the output is on if and only if the input 0 is on and input 1 is off. So, right, let's just change that then. So input 1 is, so let's just do that. So input 0 is going to be off in this case. Input 1 is going to be on. Sorry, the other way around. Input 0 is going to be on. Input 1 is going to be off. When that's the case, we end up getting green. So we need to pass this through an AND gate, because that's what it says on the hint. So I'm going to take that. What do we need to do? So maybe we could have like something going up, something going on up here, where we have... Oh, wow. Right, okay, so let's just say hypothetically we had this. It's always going to be off, isn't it? So couldn't we just do something like we have not here? Couldn't it just be something as simple as this? Isn't that it? Come on, I knew it. I knew it was going to be simple. I didn't want to overcomplicate it. Right, okay, I'm happy with that one. That was actually quicker. Right, so the general idea then is that if we turn this on, if we turn this on, then it's going to be off technically. And if we, that way, effectively, we can always guarantee that when we run this, we're going to get a green output when we have just the one tick working. So the second tick, I don't know what the purpose, I don't know, genuinely, I'd never heard of second tick before. I have, but I never knew what it meant. But anyway, let's move on. Let's go on to the next one. Right, this is the one that I'm dreading, and the only reason I'm dreading is because the moment I seen it, I knew it was going to be difficult, and it says here. So this is also known as XOR Gate. This level is difficult, so please don't be discouraged if you don't get the answer right away. Now, from my understanding, you need to use a lot of NAND gates here. So I've already got a little bit of a head start on this one. However, I have no doubt that I'm going to still be a bit confused. So I'm just going to drag a few of these on, and we're going to play around with it and see what we can get working. But the idea is then XOR, so if we have two offs, we get an off. If we have an on and an off, we get an on. If we get an off and an on, we get an on. So effectively, you only get an on if I don't know if I should be using on and off, 1 and 0. We'll say on and off for now. So we only get an on if we have an off or an on. Okay, so it's exclusive to OR effectively, all right? And I think that's what XOR means, is exclusive OR. So even if we get an AND, it's not going to be, it's not one or one. Okay, it's one X or one, meaning if you have two ones, you're going to get a negative. Okay, so exclusive to OR. Right, so let's try this then. I'm gonna play around with this for now and see what happens. And let's just pass this through. If I get this right first time, I will be blown away, but we don't know. Let's see. Right, what's happening here then? So that's correct. No, that's not correct. It needs to be producing a 1, so it's not that. Maybe we need a not in there. In fact, let's just trial and error. So if we have two offs, we do get an on. And what if we get two offs? Right, we get an off. Right, okay, so it's not going to be this. So I'm tempted to actually take a hint on this, because this is one that is genuinely confusing to me. And again, it's... right, let's have a little look. Let's play around with it. So we have... I don't know what the hell I'm doing here, by the way. I'm just playing around with it. So maybe we need a not beforehand. So let's just clear these all up. We get rid of that. So my guess is we're going to need a few NANDs. So I'm going to get these in, not ANDs. We need these. I have a feeling that we're going to need a not beforehand somewhere. And I feel like we're going to need another NAND after. Possibly. Or maybe I'm getting my wires crossed here. Let's try it. We'll give it a go. So we'll have this. We'll have this. We'll have this. We'll also have... okay, yeah, see, I'm just getting messy now. I think I'm being a bit sloppy, but we'll try it. I don't know the hell. If this works, it'll be a miracle, but we'll see. Right, what's happening? Right, okay, well, that's already wrong. Yeah, I don't know what I'm doing here. Sometimes you just got to play around with these things and see what output you get. I don't know if, again, I think we're going to have to take a hint on this one. So let's give that a go. Let's take the hint. So the truth table tells us that the output is on if and only if either the input. Yeah, actually, I get that. It makes sense. But it's saying we need two ands and an or. Well, I feel like we're going to need an or in there, actually, aren't we? So maybe I'm getting... wait. Maybe I was right or similar the first time. It was meant to be the same last time, but I don't know. Maybe I need an or here. Oh, no, I can't. Oh, wow. Right, okay. Right, I don't know what we should do here. Let me have a look a sec. XOR logic gates. You can't see where I'm searching. I feel like this is going to be a very tricky one, so I'm happy to search online. I don't want to get the direct answer, but I would like some more hints. Right, okay. So let's have a little look at the hint again. Did I get it across? Right, okay, no. So it's saying we need an and, and an or. Okay. Right. Okay. let's try that then. So we need an and an O. So let's try that. And O. So let's just connect this up and see what it gives us. So we get okay, maybe we need to, okay, let's just connect that up a second. Right, okay. So currently then we have, okay, if we pass through this, we get an on, which is what we expect. We get an on, which is what we expect. This is the issue here. If we have that, so let's try and get rid of one of these, and let's bring in a NAND. What happens then? So that's fine. Right, so we get on for that, which is clearly not good. So that's not good. Okay, let me try something else out. Right, let's drag this up here because I don't like it to get messy. If I just do this, how would that work? So that's still giving us the same. What if we did this? I'm just crossing wires over now and seeing what happens. So that still gives us the same output, doesn't it? Okay, right. So I'm going to need a hint again. Right, it's saying we need ands and ors. I don't think that's the case. What I'm going to do is I'm going to swap these around, see what happens. So is that correct? It is. Oh, I keep on pressing there as if it's going to do it. Right, that's correct. That's correct. And we put both of them on as the moment of truth. That's correct as well. Okay, right. So it seems like we've got it working. So let's try and get our heads wrapped around this then. So quite literally we have, if we have this, this is going to always be a positive no matter what we get, because as long as we've got a positive, it's going to be a positive, which is what we need. Not and, on the other hand, is, again, no matter, so effectively here we have an and. It makes sense now because we need to remove the and, so we need a not and in there. Again, that's the bit that I'm struggling with, is like thinking about this logically rather than like as a, like that hint there was probably more confusing. I don't know, I wonder, let's have a little look. First of all, let's check it's right. It is. Okay, great. Gonna close that down a sec. Let's have a little look at the solution they give. Wow. Oh wait, no, that's another hint. Right, okay, I thought they would automatically, right. Okay, so it had a different solution. So there, it goes to show there's different ways of coming up with solutions. So maybe mine was a bit more complex, or actually probably a bit easier actually, because I think I had less logic gates in there. So fantastic. Okay, that's it then. I think I'm happy to leave it at that. This is a really cool game though. I mean, talk about a game that is both fun and educational, because, you know, again, people who are I guess, you know, I say fun lightly because I think people who aren't interested in low-level programming would have no interest in this at all. But if you are interested in logic, you don't even have to be low-level programming, really. It could be maths and such like that as well. You can literally work up to when you create a working computer, which is literally insane if you think about that. And you can create your own assembly language and do some programming. It's absolutely nuts. So I can certainly see myself playing around with this more, even in my own time, if I don't get a chance to record videos on it. But yeah, I think that's probably a good place to end it for this video. Right, so I know this video was quite brief, okay, and I do appreciate that. I had fun making it though, right? And I have got a fun project that I'm working on to finish off this C learning journey that I'm on. And I say finish off lightly. I'm going to be writing C for a long time, but just to like move on to other things, to make videos and other things. And that the project is effectively me creating, in fact, I don't even know if I should say it. I'll say it, but take it lightly. I'm creating a Minecraft clone in C. That's my goal. Will I get it complete? Will I get a full working Minecraft complete? Absolutely not. I want to stress that I'm a beginner. I'm struggling at the moment, and that is why this video is actually a bit of a delay. Creating a Minecraft clone in C is fantastic. It's fun. It's teaching me a lot about, you know, well, effectively with OpenGL, which is something I've never had experience with before, other than a little bit of Raylib, which you've seen on the video, and I didn't really go much past that video. I just, got a few things working. But I'm having fun. I'm having fun in the idea of the project, creating something that is working in C, that is a game, which is also teaching me to learn something else along the side of it. It's quite fun, it's quite challenging, and I enjoy that. Now, I'm being very strict on my AI usage, again, with the project. I've never really talked about my policy on AI before, how I learned the program. Effectively, I never get AI to write code for me, and I only get it to explain things for me. And I think that's a good way to use that as a tool rather than something that's going to limit you, especially learning low-level stuff, because I think that it's not good enough for low-level programming at the moment. I have a lot of respect for everyone who's a low-level programmer, and that's why I love this community so much. Everyone who watched the video and everyone who's commented have been absolutely so supportive, and it means the world to me. So I just want to say that, really, from the bottom of my heart, thank you to everyone who subscribed. Thank you for tuning into these videos. I really didn't think that we would grow the channel as much, or that I'd find as many people as I have who are interested in low-level coding. So the fact that we've gone this far is absolutely phenomenal. So thank you again to everyone who's followed. Stay tuned for the Minecraft project, and don't get your hopes up for that. It won't be a fully working Minecraft clone. It'll be like a few cubes blocked together, and I'll be talking about my experience in making that project. Again, I thought it would be a good thing to top it off coming up to the year's end now of learning C. Right, I'm going to leave it there. Thank you for watching. I hope you enjoyed. Make sure you go get this Turing Complete game if you're interested in low-level programming. Thank you to those who suggested in the comments, and I look forward to seeing you guys in the next video as always.